is due tomorrow. We have to finish it. Please tell me you started something.
I made the title.
You're kidding, right?
I wish I was.
Did you even do any research?
Not really.
Oh my god, I want to sleep. What are we gonna do?
Let's get this done!
I wish the scientists could just explain to us what they did.
20 minutes later.
Well, where are we? Who are you?
I am John Dalton.
What are you working on?
Well, right now I am finishing my research. This is what I have discovered. I have observed elements combining in whole number ratio to form compound. To form these compounds, they undergo a chemical reaction. And by the law of conservation discovered by Anton Lavoisier a few years ago, no new matter is created and no new matter is destroyed. Since the matter is conserved, I reason that elements are made of tiny indivisible particles, which we will call atoms.
So is this how an atom looks like?
Yes, I call this the solid sphere model. It cannot be divided into smaller particles or pieces. Shoo, let me finish my research.
Hey, I'm JJ Thompson.
What are you eating?
Plum pudding! You know, I based my atomic model on plum pudding. I was so original to call it the plum pudding model. I zapped atoms with electricity, and particles came out. These particles were negatively charged. I called them electrons. I reasoned that atoms were mostly positively charged fluid with tiny electrons. I also figured out the charge to mass ratio of an electron using a cathode ray tube. In the tube, the negatively charged plate emits a cathode ray. I observed the invisible ray to be attracted to positive charges, so I reasoned that the ray must have electrons. Using some physics, I determined the charge to mass ratio of an electron, which is negative 176 million coulombs per gram. Now, are you sure you don't want some plum pudding?
No, we must go.
Oh, hi, I'm Robert Milliken. Sorry about the mess here.
Oh. Ew, why is the table so oily?
I was just experimenting with my oil experiment. I cannot actually show you right now, but I can show you the pictures of my experiment. I sprayed some oil into the upper chamber using an atomizer. The oil droplets fell through the hole and into the upper plate into the chamber between the two charged plates. I used an X-ray source to give the droplets a negative charge. At a certain voltage, the oil droplets can be suspended. When the drop is suspended, the force that is pushing the droplet down is equal to the electric force that is applied. So the applied electric field is equal to the charge of the drop. Knowing this, I solved for the unit of charge for an electron and the mass of an electron. Well, if you guys want, I can perform the experiment for you guys again. Just let me go out and buy some materials.
Hello! Welcome to my lab, the lab of Ernest Rutherford!
Hi.
Let me demonstrate my atomic theory to you. Let's play a game! Throw these alpha balls at the balls at the center, which is the nucleus. See how hard it is? A lot of alpha balls pass through and few of them bounce back. Well, you guys have awful aim, so let me demonstrate. See, I can actually throw, so I always win this game. I did this once, shooting alpha particles at thin gold foil.
Oh, I remember those. Alpha particles are particles that then consist of 2 protons and 2 neutrons.
Are you two listening to me? Anywho, I shot the alpha particles and the same thing happened. Most of the particles went through while some bounced back. This led me to the idea of a positively charged object in the center of the atom. I call it the nucleus. This led me to create the nuclear model. In my model, which is superior to the others before mine, the atom is divided into nucleus and electrons. The nucleus is positively charged. It is small and dense at the center of the atom. The tiny negative electrons are in the empty space circling the nucleus. Now, do you want to play another game? I never lost to anybody!
Oh no, we must be going.
You're leaving me? They left me. And I have a mustache and everything.
Dear Diary, the year is 1913, and today... Hello, my name is Neil 4, and I was not expecting visitors today. Here, let me show you something cool. When certain elements are exposed to a flame, certain colors are created. This has led me to create the solar system model. I have reasoned that electrons must revolve around the nucleus like the planets revolve around the sun, which have different energy levels at different distances, creating a different flame color. Here, let me show you this. Can you guys do me a hand? Let's go.
This room looks familiar.
Oh, it's him again.
Yes, it is me! Ernest Rutherford! Hey, I've seen you two visited me 7 years ago. Have you come for a rematch?
Well, fortunately for you, I'll make this game even more challenging. The objective of this game this time is to knock off the particles of these nucleus with these alpha balls. Take it. Isn't this beautiful? I see you guys haven't been practicing for these past 7 years. Let me show you. Let's go with it. Still haven't lost? Now let me explain. I did this with real alpha particles, and I knocked off positively charged particles, which are photons. I call this the proton model. In this model, I tweaked it so the nucleus is made out of protons, and the tiny electrons still revolve around the nucleus. Now, what do you say? Round 2? Let's go. You're leaving me again!
Students should not be in the classroom without a professor present. Are you my students? You don't look familiar.
No, but we just had a question about that.
Oh, well, this is my election cloud model that I created in 1927. I have studied physics and tried calculating the behavior of electrons by observing the behavior emitted by an atom. This led me to discover the principle of uncertainty. I discovered that it is impossible to locate an electron at any given time, and it is impossible to follow its orbit. Thus, I created a model in which the electrons do not follow a path, but instead orbit around a cloud. So, any other questions?
No, thank you, Mr. Heisenberg.
The Journal of James Chadwick.
What's this?
What are you doing in my lab?
Sorry, we were just looking.
Well, look with your eyes and not with your hand. This is my model of the nucleus. You see, I performed many experiments using a neutron chamber and an ionization chamber. Alpha particle will produce this from decaying polonium and in the neutron chamber, and they hit a beryllium target. When particles hit beryllium, it releases the particles with no charge. I call those particles neutron. So I concluded that the nucleus must also consist of neutrons in order to hold the protons together. So are you guys done looking? Because I need to go back to my work.
Yes, Mr. Chadwick, thank you.
Oh my gosh, we fell asleep? What time is it?
It's 2 o'clock, but it's okay. I just had a dream where all the scientists explain all their experiments.
You had that dream too? That's so weird. Whatever, let's just get this done. Okay, it says here that in the 1960s, particles called quarks were discovered. Quarks combine to form protons and neutrons. So now the atomic model looks like this.
Oh, I see. The nucleus consists of protons and neutrons, which are both made of quarks. The nucleus is surrounded by the electron cloud, where the electrons circulating the nucleus can be found.
So we have all the information down.
Let's get a snack. I'm hungry.
Me too.
Do you want some plum pudding?
We're using atomizer.
Atomizer.
Don't eat all of it! Don't eat all of it!
We're using atomizer.
I just had a scientist dream.
You're eating so
I use an S-ray.
Stop eating! Okay.